So let's talk about a term you hear literally everywhere these days, machine learning. We know it's a huge deal and it powers so much of our world. But what is it really? You know that feeling, right? You finish a show and just like magic, the next perfect recommendation is sitting right there. Or how does your email inbox just know what's junk? Well, that's not magic, and it's definitely not some person programming it all by hand. It's machine learning working behind the scenes. Okay, so to really get what makes machine learning so special, you have to understand the old way of doing things. For decades, programming was all about writing super specific step-by-step rules. If this happens, do that. If you see this word, it's spam. But just imagine trying to write rules to identify a cat in a picture. You'd have to account for every breed, every angle, every lighting condition. It's impossible. The new way, the machine learning way, just flips that whole idea on its head. Instead of feeding the computer rules, we feed it examples, tons and tons of examples, and we let the computer figure out the rules for itself. And the best way to wrap your head around this massive shift is with an idea we all get, because this whole process is actually surprisingly human. Seriously, think about it. You wouldn't hand a toddler a textbook definition of an apple, right? It's a pomaceous fruit of the rose family. Of course not. You just point to one and say, apple. You show them another one, apple. Then you show them something different and say, orange. You do this over and over, and what happens? Their little brain starts to see the patterns on its own. The roundness, the red color, the stem. They build their own internal rules for what makes an apple an apple. Well, machine learning is basically that, but for computers. So let's take that idea and peek inside the computer's classroom. How does a machine actually go to school with all these examples we give it? It really comes down to four main steps. First, you've got your data. These are the flashcards, right? The thousands of pictures of apples and oranges. Next, there's the algorithm. This is the actual learning process the computer uses to sift through all that data and find patterns. Once that's done, you get the model. You can think of this as the knowledge the computer has gained. And finally, you use that model to make a prediction. That's when you show it a new fruit and it makes its best guess. And that word algorithm can sound a little intimidating, but it's not that complicated. Just think of algorithms as different ways to study. One algorithm might be like cramming for a test. Another might be more like making detailed flashcards. They're just different strategies for learning from the data. So then the model is what you get after all that studying is done. It's the trained brain, the finished product. It's basically taking all those patterns from the data and is now locked and loaded, ready to be put to the test on something new. Okay, we've been using a lot of analogies. Toddlers, flashcards, classrooms. It's great for getting the idea. But what does it actually look like when a programmer tells the machine, okay, time to learn? You might be shocked by how simple the command is. This is pretty much it. One line of code. Model.fit is basically the command to go learn. It's telling the computer, hey, take this learning strategy we picked out and fit it to the data we're giving you. That X-train part, that's our giant pile of pictures, the examples. And the Y-train, those are the answers, the labels telling it which ones are apples and which are oranges. The whole command is just figure out the connection between these two. And after the model has done all its studying, well, then you use this command. Model.predict is basically you holding up a new piece of fruit it's never seen before and asking, all right, what's this? That X_test is the new mystery item. The computer then uses everything it learned to give you its best guess. And that's it. That's the whole cycle, from teaching to testing. Okay, so let's zoom back out. We've talked about the concept, we've even seen a peek at the code. But where does this actually show up? The truth is, it's already running your life in ways you probably don't even notice. Think about that spam filter in your email. It's just a model that's been trained on millions, probably billions of emails that people like us have marked as spam or not spam. It learned the patterns of what junk mail looks like all by itself. And Netflix or Spotify, their models have learned from what millions of people watch and listen to, and they use those patterns to predict what you specifically are going to love next. It feels like mind reading, but it's just really, really clever pattern recognition. So after all that, what's the one simple idea you should walk away with? Let's just boil this whole thing down to its absolute core. If you remember only one thing, let it be this. Machine learning is teaching computers to learn from data instead of hard-coding every single instruction. That's the whole game. It's this massive shift from giving commands to just providing examples and letting the computer connect the dots.
And that kind of leaves us with a pretty mind-bending thought to chew on. We've just talked about how machines can learn from experience, from examples, in a way that feels a lot like how we learn as kids. So the real question becomes, what are the limits? If they can learn like us, what can't they learn? Something to think about.